ray diagrams demonstration. I've included this because I've noticed that in a lot of exams, there's sort of some 2, maybe even 3 mark questions which are required to draw rays and then interpret them in terms of the position of an image. And I've often found that students find these really hard. So I'm just going to talk you through how you should be going about this. Okay, in this one we've got 3 rays. Now often you'll be asked to include 2. Really just follow the question as it is, and in this case we're looking at 3. We've got A, B and C. And all I'm going to do is the first thing, which is just to extend all of these rays and think about their reflection. Now before we do that, we have to remember one point, which is that for each of these rays, the law of reflection is going to hold. In other words, because we're using a plane mirror, the angle of incidence is going to be equal to the angle of reflection. That's where it'd be really useful if you had a protractor, a ruler, and a pencil for doing this. You're going to see that mine isn't quite perfect because I've done it on a computer. I've tried my best, so hope you forgive me for that. But where you're doing it, try your best to sort of measure the angles and draw everything as accurately as possible. Okay, first thing we're going to do is extend rays A, B, and C so that they hit the mirror. Obviously, we want reflection to occur. We're going to need to make contact with that mirror. Now, in order to obey our law of reflection, we have to draw something else, and that extra thing is the normal. The normal is just an imaginary line which allows us to make sure that our law of reflection is being observed. And the way we do that is simply just draw a black, in this case, dashed line at each point. Okay, so each ray has its own normal associated with it. Now this is where if you had a protractor, you'd be checking, you'd be measuring our angle of incidence, which is measured between the normal and the incident ray for each of these rays. You'll notice that they're different. The angle of incidence for A is bigger than B, and it's also different to C as well. Well, we're going to have to draw our reflected ray now. Okay, and again, these come out from those points. Now you notice this is where I'm looking at this again and thinking I'm not particularly happy with this. If I had a protractor that I could use on the screen here, I think I'd make mine slightly better. But I've tried my best to make sure that the angle of incidence in each case is equal to the angle of reflection. So this is where you should be at. And you've got 3 rays. Now, what we want to do now is think about the kind of trick that these rays play on our eyes. Because if our eye is looking at these rays, what it's seeing is those rays emerging from the surface of the mirror. Then our brain, I suppose, does something quite weird. It assumes that light travels in a straight line. And it tries to think, well, that blue line, for example, is traveling in this particular direction. Where might it have come from? But what it does is it thinks, well, that line must have originated from somewhere along here. Then looks at the red line and says, well, where must that guy have come? And again, light travels in straight lines, and it kind of projects backwards. And you notice that those 2 lines appear to be coming from the same point. Now that point is where our image is going to form. Our eye thinks that the red and the blue line both came from that one point. Okay, we obviously know it didn't, but our eyes don't know that. And so this is why what we construct is something called a virtual image. And we'll talk about that in a second. Let's check that line C does the same, pretty much. Again, if I were to revisit that, I would probably just check my angles a little bit more. But you've noticed I've kind of extrapolated my 3 lines out, and they meet at that particular point. And what I'd encourage you to do at this point is to check that your lines do the same. Simply follow them back behind the mirror so that they meet at a point. Now, if you've done that, you should notice something about the point where they emerged from. If we call the point where they started at the object, that's the thing that gave out the rays, then the point where they meet is called the image. And you should notice a couple of things. One, those 2 points are in line with each other, pretty much anyway. I could draw a straight vertical line between image and object to show that they are in line with each other. And this is something you experience when you look in the mirror. You'll notice that your mirror image is directly in front of you. So images always form directly in front of the object. The second thing you'll notice is that the object and the image are the same distance from the mirror. If you are standing 2 steps away from the mirror, your image also appears to be standing 2 steps from the mirror. If you then take a step backwards, your image takes a step backwards too. So this is how you can check if you've constructed your diagram very well, is in 2 ways. 1, do the object and image line up? And 2, are they the same distance from the mirror? And obviously, if they're not perfect, that's fine. There's going to be a little bit of error, but we should be expecting them to be roughly the same. Now, one small thing that gets students confused about is that this image is referred to as a virtual image. For this, we need to think about that trick that our eye plays on us. Remember, the light rays don't actually meet each other. They just appear to be coming from that point. So if we placed a screen, a piece of paper, for example, behind that mirror, we wouldn't see anything. There would be no image present. Well, that is called a virtual image. It is an image which is only formed in our mind's eye, as it were. The rays don't actually physically meet one another, and so therefore it is not real. Real being the opposite of virtual. Okay. Again, we notice, however, that the image is the same distance from the mirror as the object. Okay, so really to hammer home that point. Just have a look at your diagram, check those points, and then you'll have a chance to practice this in a couple of follow-up past paper questions.